Welcome to the second part of the writing chemical formulae video. I'm feeling rejuvenated after the first part. I had to take a break, have some lunch, and now I'm feeling raring to go. So I'm going to skip through a few slides and start with the valency table. Can I just reiterate, it's a really good idea to print out a valency table to have in front of you while you do this tutorial video. Okay, here's the valency table again, and in the first video we looked at what to do if, when writing your formula, the components of the compound have the same valency, and what to do if they have a different valency. So we also looked at substances which sometimes have a valency of 2, like iron, and sometimes have a valency of 3, and so, like copper. Copper sometimes has a valency of 1, and copper sometimes has a valency of 2. But in this second video, we're going to introduce sort of a new type of particle. So you'll notice that on the first video we didn't look at things like ammonium, we didn't look at hydroxide, nitrate, hydrogen carbonate, sulfate, carbonate, and phosphate. And that's because they're slightly trickier, so I thought I'd save it for the second video. We call these things compound ions, and that's because within the particle, within sulfate, we have two different elements. Okay, within carbonate, we have two different elements. Sometimes you could have three different elements, like in hydrogen carbonate. And notice the ATE at the end of a name, and that indicates you have oxygen as well as the element at the start of the name. So sulfate has sulfur and oxygen in there. Carbonate has carbon and oxygen. Phosphate, phosphorus and oxygen. So we're going to use these compound ions now in our formula writing. So make sure you've got a print out of this valency table, and let's get started. Right, we've got 5 examples to have a look at, and then there's another test yourself exercise over leaf. You might want to have a go at these before I even start, in which case pause the video, have a go at the 5, and then see if you got them right. Or you might get halfway through and think, actually, I can do this now. So pause the video, do them yourself, and then check you get the right answer. So, potassium nitrate. Now, what I'd like you to do is do this in exactly the same fashion. So, potassium has a valency of 1. And nitrate, which is NO3, also has a valency of 1. Now, whatever happens when we're doing something with nitrate, we always have to make sure that NO3 appears in the formula. We never change it from being NO3. We might have multiple lots of NO3, but it must say NO3, because this bit here tells us that it is a nitrate. And if I start mucking around and changing how this is written out, it no longer tells the chemist that we have a nitrate. Now, in this example, this one's quite nice and easy. Can you remember what we did when the valencies were the same? That's right, we just had one of each. So we have KNO3. Okay, notice I've kept my NO3 there. So I've got 1 NO3, 1 nitrate, and 1 potassium. Right, you might be spotting what comes next. What happens if the valencies are different? Well, magnesium sulfate is a nice example for that. So magnesium, find it on your valency sheet, has a valency of 2. Sulfate, SO4, has a valency of 2. Oh, these are the same. So, what do we do if they're the same? Well, we just have one of each. It's almost as if we just cancel them down. So we just have one of each, like we saw in the first video. So we make sure we write out magnesium, one of those, and 1 sulfate. Okay, so we must make sure we write it out as SO4. We don't start messing around with this number here, otherwise it's no longer sulfate. And you might be thinking, well, how do I show if I have more than one of these? And I'm going to show you that now. So let's have a look at iron 3 hydroxide. Here we've got iron. Well, it's told us that the valency is 3. Hydroxide sometimes gets ignored as a compound ion because people, I don't know why, but it sometimes gets ignored. I find that when marking work. Has a valency of 1. Ah, they're different. So what do we do if the valencies are different? We swap. So we now have 1 iron and 3 hydroxides. So I show that, okay, by putting a bracket around the OH and then a 3 afterwards. And what that 3 here means, next to the brackets means we've got 3 of that whole bracket. Okay, which means because we put the bracket around it, we keep it as a hydroxide, but we have 3 hydroxides. If I just wrote out FeOH3, that would mean that we only had 3 hydrogens and 1 oxygen. There's nothing next to the oxygen, so that implies we just got 1. And of course, that's not right. Okay, so we avoid writing that. Let's put a line through that. And you might think, okay, well, if we've got 3 lots of that bracket, maybe it's easier that we write Fe3. Oh, sorry, no, you wouldn't write Fe3. You'd write FeO3H3. Because if I had 3 lots of that bracket, in total that means we do have 3 oxygens and 3 hydrogens. And you would be right to a certain extent. You do have 3 oxygens and 3 hydrogens. So the actual number of particles in this formula is correct. But we always keep the OH together, just as OH, because in chemistry language that tells us we've got hydroxide. If I gave this formula to another chemist, they'd know the right number of atoms, but they wouldn't know the arrangement of the atoms. They wouldn't know it was a hydroxide. There are multiple connotations of what O3H3 might look like. So we ignore writing that as well. We keep it together. Okay, and you'll see other examples of that in the video. So I'm just going to hopefully rub it out, or not maybe. The video has started to play up. Okay, right, I'm just going to carry on with ammonium oxide and hopefully squeeze it into this space. Let's see. Right, so ammonium on the handout, not the handout, the valency table has a valency of 1, and oxide has a valency of 2. We swap them over. So we're going to have 2 ammoniums and 1 oxide. Now this time you can see that our thing at the front, ammonium, is our compound ion, and we've got 2 of those, which means the brackets are going to go at the front. Now that doesn't matter, that's absolutely fine, and that's what we'd do there. So that means we've got 2 lots of everything in that bracket. So in total we've got 8 hydrogens, 2 nitrogens and 1 oxygen, but we need the brackets there to show that we have ammonia. And the final example, aluminium carbonate. We've got aluminium, which has a valency of 3. It's getting a bit disorganised here. Carbonate has a valency of 2. So we're going to swap those over. So we've got 2 aluminiums and 3 carbonates. Now, aluminium is not a compound ion, so it doesn't need brackets, but carbonate does. And you need to wrap up the CO3 in brackets. So we'll have aluminium 2, and then here's our CO3, excuse the shoddy handwriting, and we've got 3 lots of the carbonates, so I'll put my 3 in there. Students sometimes look at this and say, oh, hang on, you've got a 3 next to another 3. Wouldn't it just be easier to write 9? No, because remember what I said, we have to keep the compound ion looking as it did in the valency table. Now hopefully that gives you an idea of how to use these compound ions when writing formulae, but really to become competent at writing out formulae you need to do huge quantities of practice. So I've put another set of formulae on the next page that hopefully will help you to consolidate your knowledge, but really you need to be doing dozens of these. So maybe pause now, have a go at the ones over on the next slide, and then I will run through them quite quickly with the answers. Okay, so here are the answers with a little bit of working out, so I'm not going to talk too much. We've got ammonium, which has a valency of 1, bromide, which has a valency of 1. They're both the same, so right, NH4, Br. Zinc chloride, Zn, has a valency of 2, chloride has a valency of 1. We swap them over, so chloride is up there, also the 1 is up there, 2 comes down here. So we write ZnCl2. Iron 3 sulfate. Oh, here's an interesting one. So we've got iron, which they've told you has a valency of 3. Sulfate has a valency of 2. And we swap those over. And notice we've got, I'll just finish that off. We've got 2 and then a 3. So we've got 3 lots of a compound ion. So let's not forget our brackets around the compound ion. So we've got 2 lots of iron, and then here's our compound ion SO4, and then we have the 3 afterwards. Calcium hydrogen carbonate. Calcium has a valency of 2. Hydrogen carbonate, which we don't often see, has a valency of 1. We swap them over, so we've got 1 and a 2, and we've got 2 lots of a compound ion, so we're going to need brackets around the compound ion, so that's going to be CaHCO3 2. Lithium nitrate, well, lithium has a valency of 1, nitrate has a valency of 1 as well, so they're both the same, so we can just go with LiNO3. We don't need brackets for the nitrate if we only have one of them, makes things a little bit more straightforward. Barium hydroxide, barium has a valency of 2, hydroxide has a valency of 1. We swap them over, so we've got 2 and 1. We've got 2 lots of a compound ion, so we'll write that as Ba and then bracket the hydroxide. We'll have 2. And to finish off with, we have ammonium carbonate, and that's going to be very tricky for me to write out because there's not much space at the bottom of my iPad screen, so I've got a load of other icons on here. So let's do our best. We've got ammonium, which is 1, and carbonate, which is 2. We swap them over. Okay, 1 and 2. We won't need brackets for carbonate because there's only 1 of them, but we will need brackets for ammonium because there's 2 of them, and ammonium came first, so we have ammonium in the brackets and 2 of them. I'm struggling to write on my screen, and then carbonate here. And that concludes this video, but please practice, and check you're getting the right answers. And if you're not getting the right answers, either come back to this video or ask someone for some help.